On the morning of January 7th, 2025, a different kind of fire rolled through the Pacific Palisades. Driven by Santa Ana winds gusting at 100 miles an hour, the flames jumped 8 lanes of freeway, obliterating highly developed neighborhoods before lunch. By the time the smoke cleared a month later, 14 separate fires had eaten through 57,000 acres around Los Angeles. 18,000 structures were gone. While the official death toll sat at 31, a peer-reviewed study accounting for smoke exposure and delayed medical care put the real number at 440. Beyond the physical destruction, the economic impact was immediate. Property values across the affected areas dropped by $8 billion, leaving communities in gridlock while insurance companies argued over the payouts. In 2025, the United States logged $23 billion weather disasters, about one every 2 weeks. These events arrive faster, sit over regions longer, and inflict damage across air, water, fire, and land simultaneously. Emergency management agencies used to prepare for isolated events. A drought was managed in one cycle, a flood in another, and they rarely intersected. For every degree of warming, air holds 4% more water. This triggers a chain reaction. Heat domes drive droughts, priming hillsides for wildfire. Fire strips roots holding the soil. When heavy rain hits barren earth, massive mudslides carry toxic ash into populated waterways. The danger is no longer just the high temperature itself, but the way these elements now stack into compounding chain reactions. If the climate is the trigger, our urban planning has become the magnifier. This aerial view of the Texas Hill Country shows the result of building using maps that are decades out of date. Developers are selling mortgages and building neighborhoods in the natural paths where water now flows. We have increased urban density by paving over wetlands and confining rivers to concrete channels, trading natural absorption for immediate expansion. When extreme rainfall hits these impervious surfaces, the water has nowhere to drain. It overflows into building foundations and streets. Designing cities without these natural escape valves turns heavy rainfall into a human-made catastrophe. We have the engineering lessons required to harden homes against these threats. Yet when local officials try to enforce resilient building codes, they often face pushback from homeowners who prioritize property aesthetics over safety. These planning failures generate hidden costs: the 9-day insulin shortage, the permanently closed small business, and the abandoned community. This is the failure loop. We build in danger zones, ignore the changing climate, suffer a disaster, and then rebuild the exact same way on the federal dime. By repeatedly paying to rebuild vulnerable properties, we subsidize the choice to stay in harm's way. Society is not helpless, but survival requires a shift from fighting the elements to designing with them. After a 1953 flood killed nearly 2,000 people, the Netherlands launched a project called Room for the River. They moved dikes back and lowered floodplains, deliberately giving the river a predetermined, safe place to go during extreme precipitation. The World Bank has calculated that every dollar invested in climate-resilient infrastructure returns $4 by avoiding future repair and rebuild costs. Cities like Singapore are now applying this logic, converting rigid concrete drainage canals into vegetated park streams that absorb storm runoff during heavy rain. Modern resilience is about building a system that safely accommodates the inevitable overflow. There is a deep well of place-specific knowledge in indigenous communities that have lived sustainably through environmental shifts for generations. In Australia, fire authorities work with Aboriginal practitioners on cool burns. These controlled burns at specific times of the year eliminate the fuel loads that would otherwise lead to catastrophic fires. The Maya Milpa system in Mexico rotates corn, beans, and squash through forest plots. This method maintains soil fertility and biodiversity while storing carbon in the regenerating forest. The most powerful survival kit marries this ancient ecological observation with modern technology, like AI early warning systems and satellite weather modeling. The atmosphere is already locked in. The next fire is gathering, and the next river is rising. The communities that survive will be the ones that listen to local ecosystems and refuse to keep building monuments to a climate that no longer exists.